Okay, then today we will learn something related to operator overloading, and if time permits, we will learn something related to lambda expression. Okay, and this is operator overloading. Actually, we will also added something related to lambda expression. If time permits, we will learn something related to that. Okay. First of all, operator overloading. So operators, and these are the operators. So they are originally defined for numerical computations. Okay. Then operator overloading is to use operators for built-in data types and also for user-defined data types. That is, we use operator overloading for classes. So originally we use it for the built-in types such as integers, float, and double numbers. Now we use it for classes. Actually, originally operator overloading is just a syntactic sugar. That means we can use, for example, for a given class, we can just add a member function, add obj like that. And then now we want to use this is o.add obj. Now we want to use o plus obj, right? Like this. So this is the syntactic sugar. Pops up. Anyways, okay. Okay, then the syntax of overloaded operator is similar to a function. So just the function name is operator add. So for this add, the function name is operator add. Right. This is function name for operator overloading. So it's just a special function. We just regard it as a special function. That's enough. Okay. So our suggestion is that we should only use operator overloading when there is a good reason. For example, if it has very good, better readability or writability, or operator overloading is also can also use for STL. For example, if we define a complex class to represent complex numbers, then plus should be better, right? It's very good operator overloading. And there are two ways of operator overloading. One is overload as member functions. Another way is overload as friend function. Actually, this friend can be omitted. We can just overload it as a general function. Okay, so friend is not necessary here. Okay, friend is not necessary here. We use friend, we use friend to access private members, right? Private members of the class. It makes things easier. Okay? So this is an example. The complex number, for complex number. So we have overloaded the operators. Here is how we overload as friend function. So overload as friend just to, access members of this class directly. So this is how we overload as minors, and for this assignment, we will learn it later. And this is how we write the overloaded function, overload operator for plus. So we just return a complex number to use these two. So this is general function, right? This is general function because we have overloaded as friend, so we can access the members directly, no matter it's private or public. Okay, then this is how we use overloaded function. I think this part is not difficult to understand, so I will skip this part quickly. Then there are some restrictions on operator overloading. For example, first one is that we cannot change the usage. For example, we use stream to output something. We always output in this way. We can so we cannot use it in this way, right? If we overload the stream operator such that we can use it in this way, that's not possible. Okay. And we cannot define new operators. So, for example, for this one, actually in Python language, this is for exponential, right? I remember it's for exponential. However, in CPP language, we do not have this, right? So we cannot overload such an operator because in the language, in CPP language, there's no such operator. And we cannot change precedence rule. So in our precedence rule, this multiply has higher priority than plus, so we cannot change it, okay? And we cannot change the number of operands. So for this +1 and -1, it is a unary operator, so we cannot change it to binary operator. And these are binary operator, we cannot change it to unary operator, okay? And there are some operators we cannot overload. These operators cannot be overloaded, okay? So we mentioned that there are two ways to overload operators. So first one is overload as member functions. So we assume two objects, x, y, are of class type. So this is class name type. So for binary operator overloading, we overload in this way. So we want to use it in this way. Actually, we are using it in this way. So we are calling a member function named operator at. Operator at. So this is the function name. Okay. So if we overload this operator, then we should declare it in this way, right? This is overload as member function, right? Because we are calling it in this way, we have one member, one parameter here, right? So we have one parameter in this function. Okay. However, for prefix unary operator, prefix, so that means this is plus for I, for example. So this is how we if we call it in this way. Sorry, this is postfix, right? Prefix. So this one. So actually, we are calling it in this way. Right? Calling it in this way. So this is member function for prefix. And then for postfix, if we call it in this way, then it is equivalent to this one. We're calling, we use a dummy variable here to differentiate between prefix and postfix. Okay. So if we want to declare a postfix, we just use in this way, right? We just declare it in this way. So this is dummy integer. Okay. So this is the way to overload as member functions for operators. Okay. And then so this is prefix. So for this class byte, we have some character here as member. Then if we want to +1, then we just +1 for B, right? For this character B. Then we return it. Right? So this is prefix. Now let's check postfix. So for postfix, we have a dummy integer here to differentiate between prefix and postfix. And then first we store the original value. Then we +1. Then we return the original value. We know that this is the semantics of postfix, right? So postfix means first return the value and then +1 for the original value, right? So this is how exactly how it behaves for the semantics of postfix. So from the two function body, we can see that which one has higher efficiency. Which one has a better efficiency? 就哪一个性能更高一点？我们看这个前缀后缀。Prefix, correct, perfect. 对，前缀has better efficiency. So for prefix, this has better efficiency. Okay, better efficiency. So because we do not make a copy, right? We do not have the time-consuming copy, right? So this has better efficiency. So if we want to, do something for very simple example is I, for integer I. If we want to +1, then prefix should be better than higher efficiency than I++. Okay. So this is the on the overloaded as member function. Then for overloaded as friend function, again we assume two objects x, y of class named type. Then for binary operator, actually we are calling the function in this way. In this way. So we can define the function like this. We have two parameters. Which one? First one is left-hand operand. The other one is right-hand. Sorry, I think the left hand means this L and R, right? The left hand and right hand of the operator. Then this friend is not necessary. This can be omitted. Okay. And then for unary operator, if we call it in this way, this is prefix, then we are calling it in this format. So we declare it, the overloaded function as this. Then for postfix, if we call this postfix in this way, actually it will be interpreted as this. We have a dummy integer again. So the keyword, we mentioned that keyword friend can be omitted if we do not need to access private members, or if we can access the private members by public member functions, then it's not necessary to declare friend. Declare friend. Here's an example for class integer. So we have this prefix and postfix. We have this dummy variable here. Okay. Then this one, then this is overloaded as member function and friend function. Which one is better? So overloaded member functions are preferred, actually. Member functions are preferred because it emphasizes the association between operator and the class. We know that this operator is directly defined for this class, and it will be used for this class. It has better readability. However, there are some exceptions. When the left operand is not object of the user-defined class, then the operator can only be overloaded as friend function. So this is an example. Stream operator, because we use stream operator in this way, right? Cout something. Then this cout is not user-defined class, right? Objects. So it is objects of the standard library class, right? So we cannot overload it as a member function because we cannot modify this standard library class, right? Then this is stream operator. We can learn further about this. So originally we have this operator for integer. We can print it to standard output. So why can't we do this? Why can't we just print it, print the contents of the objects? So we can. However, we need to define overloaded stream operators. So actually, we already learned this before, right? So we mentioned that cin and cout are classes, are objects of the fundamental classes in the library, right? So actually, it's iStream and OStream. These are the two classes. So stream operator for the built-in types, we can do this. We can also do this for character string, and it has different semantics. If we directly print the string, we print the contents of the string. If we have some conversion here, then we can print address of the string. So we know that actually stream operator is already overloaded for built-in types. We can because we can see out integers and string, and for different type of the string, we can have different output. So stream operator is already overloaded for built-in types. However, if we want to overload it for user-defined types or user-defined classes, then very good question. I think just the stream operator is already overloaded in this way, right? So it's already overloaded in this way. If we just print this, it will get address and print address. So that's why the stream operator is already overloaded. So we use this example to demonstrate that it's already overloaded in the implementation of the class iStream and OStream. Okay. So if we want to overload this stream operator for built-in type for the user-defined types, then we have to overload it as friend functions, because there is no way to modify this iStream and OStream. We cannot do that. Okay. So we just mentioned that we cannot do that. Then for binary operators overloaded friend functions, there's no such constraints. Because if we overload as binary operator, if we call this, for example, if we call this cout obj, we are calling a binary operator stream, and then cout is one parameter, and then obj is another parameter, like this. So we can just overload the stream operator as a binary operator. So we can just define it, use it in this way, right? Then we can declare this operator and overload this operator. So I think now we understand why we cannot overload stream operator as member function. Then we just memorize it. Okay. Then this is the example how we overload the stream operator as a friend function. So we have the O stream, then cout will be passed in here, and then this is the object of the class. And we return this stream reference directly after output. So this is how we implement the function body. So this is my out. Sometimes our students tend to write it like just use cout, for example. In previous years, in some very simple exam, however, in this some students just write this part as cout. Actually, we should use my output. We should use my output. We cannot just use cout, right? Because we can use this for file stream, right? We can pass a file stream, right? Our file descriptor inside, right? File stream, right? File descriptor, this IF stream, EAN, OF stream, right? So we should not use cout here. This is a typical error from our students. Then we need to return this out. In this way, we can do this: cout A and cout B, and then cout NL. Right? Otherwise, we cannot do that. Okay. We already mentioned this in previous classes. So this is how we use it. We just mentioned that when we define this stream operator overloading, we can use stream descriptor, or we can use cout, standard output, and file output. Both works for this overloaded stream operator. Okay. Okay. Then assignment operator. So our question is whether this works or not if we do not define an assignment operator. Actually, it works because compiler helps us to define a default, construct a default assignment operator. So the assignment operator uses bit copy. We already know bit copy when we learn constructors, right? So we should not depend on the compiler. We should always define our own assignment and copy operators, constructors, right? And assignment operator. Okay. So we should always define our own assignment operator when the class has a point member. Otherwise, there should be some bugs, right? Then this is how we define assignment operator. So this is the parameter. Then we should check whether it is self-assignment or not by comparing the address of the two objects. So if they are not the same address, then we know that it is not self-assignment like this. Then we can do the assignment. Then we return the current and return the current object. So in this way, we can do this. Right, we can do this. Otherwise, if we do not return this, we cannot do this. Right? This change the assignment. Right? Okay. Actually, when we do this, we are doing this. Right? First, C is assigned to B, and then in this case, B will be returned. Right? Return this. B will be returned, and then we have this A equals B. Right? So we have two steps. First step is B equals C, then A equals B. Okay. Then for this, this one is to avoid copy constructor. Yes, we do not need to add these parameters. I added this to indicate the priority, okay, the sequence or the order of the assignment. This parenthesis is not necessary, okay. Then this reference is for avoid copy constructor. Then this const is to accept temporary objects generated by by automatic type conversion. And then this is for checking self-assignment. We just mentioned that. And this is for this. I just mentioned this, right? We allow this. We can also allow this. Very interesting type of assignment, right? Okay. I think we have already mentioned about this. So to avoid self-assignment, first one is for correctness, because if we do A equals A, then probably we have to, for self-assignment, and then we may need to delete some pointer members first, and then we assign it to another point member. If we implement this self-assignment, then there will be some bugs, because we will first delete, right, the pointer in A, then we assign the pointer in A to itself, then there will be some bugs. So this is for correctness. And then apparently, if we do self-assignment, it affects efficiency. And this is the example for how to define the self-assignment operator, how to define the assignment operator, and how to avoid the self-assignment like this. So for comparison between assignment operator and constructor, I think the key is to check whether memory has already been allocated. So, for example, for this one, if we do the assignment for this, if we do the assignment here, the memory for new object has already been allocated, so assignment operator will be called. However, for this example, because the assignment for this assignment operator, equal operator, then memory has not been allocated, right? We are allocating this memory for this new object, so copy constructor will be called. So this is the key. We need to check whether the memory has been allocated or not. This is an example for more assignment. So this is how we, this is the class with an array. Then if we move from one object to another, so we also need to check whether it is self-assignment. Then this is the how we move from A to this, right? Get the size, get the pointer to the array, and then set A's pointer to 0, then we return. So this is how we call the move assignment, because the memory has already been allocated. So in this case, it will be we will call the move assignment. The output for this a.print should be indefinite, right? Because here after the move assignment, the pointer is already set to 0. So probably this line, this a.print, this line will crash the program. Okay, so we should be careful when we use move constructor and the move assignment. Okay. Now we have a problem or a question for you. So for this question, we have an array, integer array here. Then we want to print something, right? Print those elements in the array that are greater than 30. And we also want to print those elements that are odd. Then this seems very good implementation. However, if we need to change, first one is that there's some code duplication, right? And second one is that if we need to change the, for example, if we want to get the even numbers, then we need to write another for loop, right? Then there's a lot of code duplication or code repetition. How to get a better implementation? We may think of using a function, right? For example, using function display, right? Then we add something to compare the elements, to use this to compare the elements, right? To get the to print the elements that are satisfies the criteria. How to implement this disp? First one is pointer to members, pointer to functions. Okay, so this pointer to functions, this is how we define a pointer to functions. This is a return type, and this is a list of parameters for functions, and this is a pointer name. So this pointer name will point to a function. So this is how we define a pointer to function. Now these parentheses are necessary. Right? We cannot omit this, otherwise there will be errors. Okay, then this is the grammar to declare pointer to functions. Then, for example, if we have a function find maximum, then pointer to function is defined like this. So we pass the function name in here, and then this is how we define the pointer to function. We can see that the parameter list are the same, right? Exactly the same. And the return type is also the same. Right? For brevity or simplicity, we can use all two. And let the compiler to determine it. Okay. Then this is a easier way. So there are two ways to define this pointer function. Then the usage are different, right? So for this one, we need to use a star before this pfun, right? Like this. Sorry. So then this is an example. We have a product function. Then we define a pointer to function in this way. Then we use a pointer to function in this way, right? Just like a function, right? Just like a function. Then we can define different sorry. For this pointer to function, actually, these all two, these are different. These are the same. Right? All two star and all two are the same. Okay. So this one is still used in this way. Okay. So this is pointer to function, and then this is another example. We have some function declarations here, and then we define a pointer to function. First initialize the 0. Then we can assign it to product. Then we can use it at the product. Then we can assign it to sum. Then we can use it at the sum function. Okay. So the pointer to function can point to different functions. Then it has different functionalities. Okay. So this is pointer to function. So here's another example. This example is actually is related to template. We will learn template next class. However, template is not so difficult in this case. We just regard this type name T as if it is a class name. Then it should be fine. So that means this find optimum, this function, can be used for any type, right? For any type T. Right? So that means for vector, the values can be of any type. Okay. Then we also need a pointer to function to compare between the two types, right? Or the two objects. Okay, and this is a function template. So this function body is easy to understand. So if value is empty, then we return, and then we first get the first value in the array, and then we check every one in the array, and then compare between the values and the optimum one by compare. So compare may be greater than or less than or greater than or other comparisons. Okay, so we just use this pointer to function to compare, right, between the two elements. Then if the comparison is satisfied, for example, if this one is less than this one, then we will use this optimum to record the smaller one. If this compare is less than. Okay, and this is the template function, our function template. Then we can use it. We can use this function template by pointer to functions. Then we can define this less, very simple function. We can also define a function template greater, and then this greater can be used to compare any type, or any type, any two objects of type T, right? As long as we have defined greater than for type T, right? Then for longer is easy to understand. Just compare the length of the two strings. Then for the user program, we first define the vector of numbers, integers. Then we can call this function in this way, right? We pass in the function, pass in function. So when we pass in the function, because this takes a pointer to function, right? So when we pass in the function, actually we are passing a pointer to function. Right? The function name takes the pointer to function, right? And pass it into this function. Then we can compare. We can also use this greater we have defined, because greater is a function template, so we can provide a type. So when we use function template, we need to provide a type. If we provide a type for int, then that means we are comparing integers, two integers, one and other. Okay, 5 minutes break. Okay, let's continue our class. So this is how we pass in the functions, function names as pointer to functions into another function, So actually, we are using pointer to functions as if it is an object, or as if it is a built-in type variable, right? So this is pointer to function. I think this is interesting for pointer to functions. Then we can also use a string vector. Then we can compare a string vector using this greater string. This greater string is also interesting because we have defined this function template. Then we pass in the string for this function template. Now we are defining a string greater. Right? We are comparing string. We are substituting, replacing every t into a string. And then it is a greater function for string. Then we can sort. We can find the smallest one. For string. For string, it is largest one, right? Greater than. We can get a largest one in all the strings. Right? Then we can also get the longest name by using this longer. Right? So this is how we use pointer to functions, right? To call higher order functions, because comparing to this less, this is pass in. Then this one find optimum looks like a higher level, right? It's a higher order function. So this is this is pointer to functions. So for our previous example, we can use pointer to functions to solve our problem. Right? We have this display. So we can pass in the pointer to functions greater than 30, can pass in this function, then we can define, we can solve the problem. So this is the pointer to function declaration, right? So seems very good solution. However, if we have many different conditions, then how to solve this? We need to define many different functions, right? So there's still a lot of work. How to solve this problem? We can use function objects. So function objects is enabled by defining a function call operator. So, or by overloading this function call operator. Okay? So because we are learning this in this class, operator overloading, so function object is related to function call operator overloading. Function object is also called functor for short. Function object or functor is an object of a class with overloaded function call operator. So function object is an object. However, this object can be used or can be called as if it were a function. So it's a function object, it's an object, but it can be used as if it is a function. So it's often used in the STL. And the function call operator must be overloaded in this format. So this is how we overload function call operator. So this is a return type, then this operator keyword, then we have this function call operator here, then we have the parameter list. So this is a function object example. So we can define a class, then we have a function call operator overloaded here. So it checks whether it's greater than 30. Then we can define a function object. Then we can use function object as if it is a function. So we pass in this number, then this number will be passed in here, and it will be checked whether it's greater than 30. Okay, and this is function object. So advantage of function object versus function pointer or pointer to function is that a function object can store parameters, can store some values. So such kind of function object is also called parameterized function objects because we can pass parameters and store the parameters in the function object so that we can do much more than just function pointers. So in this way, we can store this 30. Originally, we compare with 30. Now we can pass in the number. Right? If we pass in 30 into the function object, then it will be compared with 30. If we pass in 60, then it will be compared with 60, 80, and compared 80. Right? So this is the way to avoid the duplication. So we can store data. So we can, for greater than 30, greater than 60, greater than 80, we just use one function object. We can solve all those problems. Okay, then this is the previous example. We can just pass in the function object, and then our function object is defined in this way. We use parameterized function object. We pass in the value, then we compare with the value. So we can have many different values. We can pass in the different values, and then we can compare it. So this is a way to define a different function object so that we can compare with different values. Okay, so function object is better than function pointers, right? Because it can store data. And in our standard library, there are some standard function objects. We need to include this header, and then there are some standard function objects for comparison for other operations. For example, if we define a vector of integers, then we can use the standard function object. This is a way to define a standard function object. So actually, originally we need to provide the type int here. Now in the latest version of the standard function objects, we do not need to provide the type. We just use this. It works correctly and probably with better efficiency. So this is a way to use standard function objects. So these standard function objects can avoid some, some work from our coding. We just use the standard function objects. It works fine. Okay. So these standard function objects are actually works for the built-in types, right? For example, if these objects are from our user-defined classes, then there's no way to compare between them, right? Because there's no way to know how to compare between them. Right? We have to provide the comparison between them. Otherwise, it won't work. Okay. Then, after learning this function object, maybe time is kind of limited. We can start have a start on these lambda expressions, because lambda expressions are closely related to function objects. So lambda expression provides a convenient and compact syntax for quickly defining callback functions or functors. We know that functors are function objects. Right? So lambda expressions can be used to define function objects. Right? So lambda expressions allows definition of the callback logic right there where we want to use it. If we want to use a callback in line of code in here, we just define it here. It's fine. And this lambda expression can access variables that exist in the enclosing scope where the lambda expression is defined. So if we define the lambda expression here, then in this scope, the variables can be accessed in this scope, I think. So by function pointers, we have learned function pointers, function objects, and the lambda expressions. We may treat functions as if they are variables. Right? We can treat functions like variables. We can use functions like variables. That means we can pass functions into other functions as function parameters, and we can return functions from other functions as return types. Okay, so in this way, our C++ language provides a the first class functions. So such functions are called first class functions because they can be used as if they are just variables. Or we can use it. We can use them as if they are just built-in types. Okay, so this is why a lambda expression is so popular. This is how we define the lambda expression. So this part is the lambda introducer, and this part is a parameter list, and this part is statements, or it corresponds to the function body. Whenever the compiler encounters such a lambda expression, it will internally generate a new class type, right? Generate a new class. Compiler will internally do that. So generated class may look like this. There's some random class name, and then there's a overloaded function call operator. So this is a parameter, and this is the statement. So that's why we just mentioned that lambda expression provides a way of defining function objects, right? Because this is exactly how we define function objects. There are also some other grammar. So because we are, for example, we are kind of defining a function, right? We are defining a function as a function call operator function. So we need sometimes we need the return type. However, the compiler do that for us in most cases. So if for the return type, it could be omitted because compiler will generate the implicit conversions from the return statements. Because for example, we are returning here. So we are returning here. So they are compared to each other. So we know that it will return a bool, right? So we can just omit this part. Compiler will kind of obtain this information, right? Or derive this information for us. Okay, so this part can be omitted. Okay, then this is some introduction on lambda expression. Due to the time limit, we will stop here. And next, we will ask our students to give in-class talks. Yang Biru. Let's start our class today. So in our last class, we have learned this lambda expression. This is the beginning of the lambda expression. And then we will follow this and finish this lambda expression today. Before learning further on this lambda expression, we want to have a vote. Have a vote on the, whether we should postpone our deadline of the final project. So for all of you, please vote on this. I think there's some students still not logged in to the Ring class. 大家请各位登录一下语课堂啊，我们做个投票啊。Okay, then let's have 2 minutes to vote. When you come back to school, postpone to when you come back to school. 就下学期什么时候那个返校，我们什么时候就准备考试啊？就准备这个，当然考试是一方面啊，这个是大作业。这是大作业。那个 code reading 我们就 不再 delay 了啊。Code reading 我们还是这学期争取把它完成。因为如果全都 delay 到下学期的话，我担心大家还有其他的事情，到时候也做不过来。所以 code reading 我们尽可能在这学期完成，然后我们大作业呢，我们到下学期大家返校以后再提交。因为我们考试也是在大家返校以后，考试，所以呢，那个时候需要考完之后呢，需要给成绩。我们的考试内容，应该会有点不同，但因为课程这个上的内容也稍微有点差别，但是应该就是说大的内容上应该差不多，考试点上应该差不太多。这个我们会跟其他的课堂再商量一下，如果呢考试点都一样的话，我们也可能就采用同样的考试方式。一般情况我们往年都是考两到3道上机编程的题目，所以呢，我们要到这个东主楼的国防生机房来考试，2到3道编程题，现场完成。主要呢还是跟我们上课学的内容相关，就类啊、继承啊、多态啊、设计模式啊、模板呐这些相关的内容。Okay, we can see here. So the results is yes, right? The result is yes. So we okay. Then we should delay our final project to next semester. Okay, when we finish our final exam, then we should submit our final project so that we can get our credits. Okay. Okay. Then we continue to learn our class. So this is how we define the lambda expression, and this one is called lambda introducer, and this is where we should capture some variables, and this one is a parameter list, and this one is the function body. And the capture the parameters will be used in the function body. Okay, so for the compiler, whenever the compiler encounters a lambda expression, it internally generates a new class type. So for a lambda expression, actually, the compiler will treat it as a class. So for this lambda expression, the compiler may generate such a class. So this name is compiler a randomly generated name. And then this is actually, it is a function object, right? So this function call operator is overloaded. And this is the function parameter list. And this is function body. Right? So if we capture some variable here, then it should be used as members, right? Class members. And then it will be used in this function body. And for such a, actually this is a function call operator overloading, right? So for such a function, there should be a return type, right? There should be a return type. So this return type can be omitted, So the compiler, because compiler can infer this return type, right? Whenever the compiler can infer the return type, we can omit it. So typically, this return type is omitted. We do not need to explicitly specify the return type. Okay, then this is the lambda expression. So we mentioned that we can capture something here, but if we do not have any symbol inside, nothing will be captured. So we can only use the parameters in the function body like this. So there are two ways to use the lambda expression or to define the lambda expression. One way is like this. We define a lambda expression with a name. Another way is to directly define the lambda expression in the function call. So this is function call. We directly define this lambda expression here. So there are two ways to define the lambda expression. So this is we just mentioned that this is also called a stateless lambda expression without capture clause. We actually capture nothing. So we cannot access anything in this encoding scope. So if we have some variables here, we cannot access the variables defined here. So to access the variables in the local scope, we have to use some capture clause. This is capture clause. So we allow all the variables in the scope of lambda definition to be accessed by value. So this is the key, by value. It's similar to function call or function arguments passed by value. So if we define a function like this, so we pass some variables like this. So this is passed by value, right? We already learned that, passed by value. So by passed by value, it means we are making a copy. Right? We are copy from the arguments to this int I, to this formal argument. So this passed by value also infers that the captured values are copied. Copied means if we modify the value in the function body, it does not affect original variable. Okay. So this is capture by value. So then to illustrate the example, we have this template, function template. Actually, there are two types. One is T, another one is comparison. These two types will be used in the function body. First one, T, is for defining vector values so that all the values in the vector have the same type T. And compare is used to compare the values. So for this one, in this function, we can see that we enumerate all the values in the vector, and then this optimum records the first one at the beginning, and then we compare all the values in the vector, and then find the one. For example, if this is less than, then this optimum will record the minimum one. If this is greater than, then this one will record the greatest one. Okay, then this is a function template. We'll learn this later. And then this is how we use the function template and pass the lambda expression into the function template to compare. So we have a vector, integers, then we have a variable, then we are asked to input the variable, input the value for the variable, and then we have this lambda expression. So lambda expression captures all the values that can be accessed in this enclosing scope, in this scope, before this lambda definition. Okay, so in this case, this number to search will be captured, and then also these numbers will be captured. Actually, in this function body, we only use number to search for, only use this variable. We did not use numbers. However, we can use numbers if we want. So this one, in the function body, we can see that we actually want to find the one that is nearest to this variable, right? We'll find the compute the absolute value of the difference between the two numbers. Then we find the minimum one. Right? So actually, after defining this lambda expression, this value has already been captured into this function. So after that, if we modify this value, there's no effect on the captured value. Okay, so now we modify this value, it does not affect the captured value inside this function body. Okay, so we can see that if we input 20, then the nearest value is actually this 2. So from the algorithm, we can find it should be this 18, right? So even we modify this value to 40, the captured value is still 20, right? Still 20 because we input 20. So now this is 20. So the 20 is captured into this function body. Okay, and this is the lambda expression and the captured value. So it captures the value before and nearest to the lambda definition. Another one for this capture clause is the capture by reference. So for this vector, again, if we capture this value, and then we use this capture by reference, then we can modify the value. Otherwise, if we use this equal operator, if we use this has no effect on the value because it's a copy. Now it's reference. It's similar to the function argument passed by reference. We all know that if we define a function to pass by a reference, then in the function body, if we modify this function, this value, modify this value, then it will affect original value, right? This value will be modified. Okay. So this is similar. If we modify this value in the function body, then this value will be modified. So we can test this. You can see that we input 40, then the value is modified to 45. Why is 45? because we are calling this function optimum function, and this is compared, and this counter is for comparison, this lambda function. So there are in total six numbers in the vector, and then there are actually 5 pairs, right? 5 pairs. So counter is called 5 times. Right? That's why this number to search variable is increased by 5. And then because our input is actually this counter is different, right? We can see here. We can see here. So this variable x and y, we want to find the minimum one, the smaller one, right? Smaller one. So numbers will be passed into counter, right? Numbers will be passed into counter. Okay. So let's come back to check this find optimum again. So this is the counter now, and counter takes 2 parameters here. So these 2 values will be passed into counter, right? Passed into counter. So this is x and y, right? Then we compare the 2 and find the better one. Because now counter compares the 2 values, so we get the minimum one, right? Get the minimum value in the vector. So this is 13. Okay, then this is the 2 ways to capture the values in the enclosing scope where the lambda function is defined. Actually, we can capture different values by in different formats. So this these values are captured by and passed by value, right? Captured by value, and these values are captured by reference. So we can put all of them in this capture clause. We can also capture in another way. So for this one, if we use this, that means count is captured by reference, and all the other values are captured by value. If we write down like this, then count is captured by value, and all the others are captured by reference. Okay. There's another grammar in class. If we want to access members in class, then if we want to access members in class, and actually the lambda expression is defined within the class body. So then we need to capture this pointer to access all the members in the class. So this is an example. We have a class finder. So in this class, we have some members. Then we define this find nearest as a function, as a member function. And then we have this number to search here. So to access this variable, we may write like this. Actually, this is wrong. Okay, this is wrong. This will cause compiler errors. If we just write down like this, and this is a member of the of this class, it will output a compiler error. the correct way is to capture this, and then in this way we can access all the members in the class. This is the member of the class, so we can access it freely. We can also modify the value. Because we are capturing by this. This is equivalent to this. Okay, so it's all we can regard it as pass by reference of the object. So this is another thing to note is the optional. So this is standard library function. Actually, so this is a safe way of writing some functions. For example, if we cannot find anything, if the value is empty, originally if we just return double, then we may return some special value here, right? To note that this is wrong. However, that may not be safe because this value may be also in the vector, right? So a special value is not safe sometimes. So the standard library provides a safe way for us to do this. So if the vector is empty, we can return this. Nothing, right? It means we do not have a correct value. Otherwise, we can return the double value in this way. Return this. So this lambda expression is also defined within this function template, right? So this is this lambda expression is passed in right here. Okay. Anyway, this returns double, right? This return double. Okay. Let's check this example in more detail. Let's first check lambda. You can see this example. So we have this function template. Then this is the function template, and then we have this in the main function. We input a number, and then we try to find the nearest one to this number. Sorry, I think this finds the smallest one in the vector, and then it modifies the input value. So we can input something, then it is modified plus by 8 plus by 5, because 5 times the function are called, right? Minimum one of the vector is 13. And for capture this, something. Okay, then this is a class definition. So to use this optional standard in the standard library, we have to include this header file, and then this is the constructor, and this is some member functions to access the number, and this is the find nearest, and this is the member. And this function find optimum is similar to that one, right? Previous one. So here we did not use this optional, right? We did not use that optional class. However, we can use it, right? Because in this case, anyway, zero pointer is enough, right? In this case, zero pointer should always be able to tell us that there's no correct value, right? So zero pointer is better, right, in this case. So it's enough. That's why we did not use optional. Anyway, we can use optional if we want. Then we check this finder. So in this finder.cpp, we have this empty. No, it's empty. So we check whether it's empty, then we return. If it's empty, we return this special member, right, to denote that there's no valid return value. Otherwise, we return this. So actually, there are several ways we can try. First one, we just mentioned that this first one is not correct. We can still try it. We want to capture this member in the class. Actually, it doesn't work. We can try it. There's a compiling error. So this doesn't work. And we recommended this one. Capture this, which passes the pointer to the object, so we can access these members. Then we can see that it runs correctly. You can input any number. The nearest number in the vector is 22. So in this main function, we can see that we input 30, so this is correct answer, right? Nothing to say, I think, in this. And this is how we use optional. So in the finder, we return the optional. Use the optional for return value. Then we can check in this way. We can check in this way. We can check this. Check this, whether it's correct or not. If the return value is correct, then this should return true, and then we can use similar to use iterator. We can get the value from this. And then otherwise, it means there's some error. We cannot find the value. So this is how we use optional. It avoids us to set some special value, very weird value, and save us from some misunderstanding of the program and sometimes bugs and errors. So you can try another one. And this should not work because this is equivalent to reference, right? So if we also want to capture all the members by values, then there are some conflicts, right? So it should not work. So there are some compiler errors. However, you can use this. Although they have the same meaning, it still works. Compiler does not complain with this usage. Okay, so it works correctly. Oh, this one. So it's correctly. Anyways, our suggestion is that we should just use this one, right? It's recommended, right? If we want to capture all the members within the class, we can use this one. This is recommended way. So this is also allowed by the compiler, and this gets some error. Okay, so this is how we capture this pointer. Now we want to mention something about new and delete because they are also operators. Also operators, but they are more related to memory allocation for objects. So when we call, for example, we want to allocate or construct an object, or if we want to allocate an object array, then actually the following steps are executed. Actually, 3 steps. First one is that operator new or operator with a square, operator new is called to allocate the raw memory. So this one corresponds to this, allocate one object, and this one corresponds to allocate an array of objects. Then the second step is that constructor will be called. Constructor will be called to initialize, construct the object and initialize the variables in the object or members in the object. And then the third step is to return the pointer to the object. Return to this variable. Return to this variable. Okay. So this is the third step. Then when we call this delete, if we want to delete the object or array of objects, then the following 2 steps are executed. First one is destructor is called because it's destructor of the object or objects in the array. Then operator delete is called to free the memory. So this operator new and operator delete are special functions. They are special functions that can be overloaded. That means we can define our own operator new and operator delete to control the memory allocation and free. So for this operator new and delete, we can overload it as global functions or as member functions of a class. So when we overload this new and delete as member functions, they are implicitly static, even we do not have the static keyword. compiler will regard it as a static member function if we overload this in the class. This is because new and delete are very special steps. For example, if you want to new the object during the allocation of the memory, no data can be accessed, right? So we cannot access members in the class. So it has to be static. Static means we cannot access members in the class, right? In the object, right? So this is static. That's why these two special operators are static. When calling operator new or operator delete from an object, the compiler searches for the operators in the following order. First of all, the first one, at the beginning, the compiler will search for this operator new or operator delete in the members of the corresponding class. Or if it's a derived class, it's also search for the base class. Try to find overloaded operator new and operator delete. If it's not found, then a second step is to search for the global scope for user-defined operators new and delete. If this is also not found, then in the third step, it will call the operator in the standard library. Because anyways, in standard library, there's operator new and operator delete. Then this is an example how we overload the operator new and operator delete. So we have to overload it. This is how we overload as member functions, right? Member functions. So this is static member function or operator new, and for both object and array of objects, this is delete an object. This is delete arrays of objects. Sorry, array of objects. We have an example here. So you can see that here is the test. Actually, this is modified from online source. You can find it. I think you can find many different examples from online. If we search for new and the placement new. So this is a class, and we have some members, 2 integers actually. So it takes 8 bytes, right? 2 integers. Then we have a constructor and destructor. In the constructor and destructor, we print this pointer. So this is an address of the object. Then we have the operator new and the operator delete. So for this operator new, it is a static member function. We can still declare it as inline. In this case, if we declare it as inline, it may have better efficiency, right? So this is how we allocate memory. So because we are overloading this operator new, now we can use a lower level function. This is actually from C programming language, malloc. This is to allocate the memory of the given size. Then this size is passed by the compiler. So if we new an object, then this size is the size of the class, right? Then we can check whether the size is the size of the class, and we can check the allocated the pointer, right? the pointer to the memory. Then we can return it. Right? And then this is to allocate an array of objects. Again, the size of the array will be passed in, and then we can allocate it, and then we can return it. Right? And this is delete. For delete, the size of the array and also the pointer is passed in. We can use free. This is also C, it's a function from C programming language. It's a low-level memory free function. And then this is how we free an array of objects, similar to that one, this one. Okay, and then we allocate one for test, another one for 3 elements array of test. Right. We can check it. So from the result, we can see that first we allocate an object for test. Then this is the path size. The size is 8 because there are 2 integers, 8 bytes. And this is the pointer to the allocated memory. So in the constructor, then the constructor is called. We can see that address is exactly the same. And then in the destructor, this will be deleted. And then in the destructor, it is passed in, still 8 bytes, and the address is passed in. And then we allocate an array. So this is the pointer, the address of the array. Then in the constructor is just a little different. Right? And also in the new, the size is a little different, right? Because we have 3 elements, actually it should be 24 bytes, right? 24 bytes, but now it passes in 32 bytes. 32 bytes, this means to store an array of objects, something extra message or extra information should be stored in the array, right? For example, the size of the array, right? So this path size is greater than the objects, right? Greater than the objects. Now in the constructor, we can see that these are the addresses of the objects. And then when we delete the objects, the addresses are exactly the same. It will be deleted. And then we will free this memory later, right? When we call this delete, okay? So this gives the steps of this new and delete when we use operator new and operator delete, all of the versions. Okay, let's have 5 minutes break. Let's continue our class. So in this overloaded operator new, we can, you know, we have the low-level functions to allocate the memory. And there are also some other low-level functions, such as realloc. So in realloc, there's some pointer. This pointer can be passed as a parameter. This pointer is of type this. So this means we can start from the pointer, right? So this is the address. So if we allocate some memory, we'll start from this pointer, right? Start here, we can allocate memory. So this is another low-level function that we can control our memory. Other than operator new, we also have the placement new. We do not have time to to mention too much about this. So for placement new, basically it means we can have a memory, for example, sorry, maybe we just use memory, for example, is a very large memory, and then we can use placement new. The placement new is used like this. It's used like this. So this means we allocate the object of A starting from the address of this, starting from here. So that gives us a way to control the memory, and maybe we can use it as a memory pool, right? So this is placement new. If you have some interest, you can read more about this or learn more about this by yourself. Okay, so this is related to operator new and placement new. There are some function objects used in STL. I think this is not difficult for you to learn and understand. So I leave this part to you to learn by yourself. Okay. So typical the basic idea is that when we use STL, sometimes we need to provide some comparator, right? A comparator. For example, if in the map we have some points, so the points have x, y coordinates, then if we do not provide how to compare between the points, we cannot use map. In this case, doesn't work, right? Doesn't work. We have to provide a comparison class or lambda function to compare the points, right? So we can compare first by x and then by y, right? Compare in this way, then we can provide the comparison class into this map, then we can use it, right? So this is a basic idea of how to use STL. Typically, we have to provide some lambda function or comparison class. Okay, then another thing to note for this map is that actually the size of the map will keep on increasing. Even we do not find something at some point, the map still increases by size. So when we use map, we have to be careful about this. Sometimes for very large projects, the memory consumption from map will keep on increasing, right? So that our application may be slowed down. Okay, then this is something related to STL. Actually, there are a lot more about STL left for us to learn. We can learn it in the reference website, CPP reference, right? cppreference.com. We can learn it by ourselves. Okay, so this is for the for this part. So we can have some exercise, and also we have some optional exercise. If you want, you can do it. Okay, then probably we do not have